Hey there, grade 11s. Thanks for joining me again for today's lesson on blood types. So in today's lesson, we're going to be looking at what factors determine a person's blood type. And once your blood type has been determined, you belong to a factor of the ABO group and the RH factor. And then we're going to be talking briefly about what happens when incompatible blood types are mixed. And that's kind of the theme for tomorrow's lesson, but we'll just kind of give one example at the end of this one. So in your red blood cells, you have these proteins and carbohydrates called antigens that are kind of attached to the cell membrane. Antigens have the ability to provoke an immune response within your body. However, the antigens that belong to your red blood cells won't provoke this immune response because you've had them since the day you were born. Like they've been in your body, so your body doesn't recognize your antigens as something that should be attacked. And in your plasma, you have these substances called antibodies, and they're produced by your white blood cells. Antibodies have the ability to identify and attack foreign particles that enter the body. So your antibodies are found in your plasma, and they're going to oppose antigens that are foreign to the body. So if you look at this diagram over here, you have this this contraption here, the antibody, and at the end they kind of have these almost like a lock. And antigens are almost like the key. So you can see that they all look a little bit similar. They're obviously different colors, but they have different shapes at the bottoms. So these are the different antigens, and your antibodies might be equipped to kind of synchronize to one antigen and destroy it. So your blood type is determined by the presence or absence of these antigens and antibodies that are in your blood. So you may have heard of blood types before, but you can have blood type A, where you're going to have the A antigen on the outside of your red blood cell. You can have blood type B, where you have the B antigen on the outside of your red blood cell. Blood type A and B, you have both antigens. And then blood type O, you have neither. So we use two major blood group systems, the ABO group, which I just described there. And then we also have the RH group. So this little black square here is the RH factor or rhesus factor. And either you have this antigen on your red blood cells or you don't. So if you have it, you're considered positive. If you don't have the antigen, you're considered negative. Blood types are genetically inherited. So your parents' blood type kind of determines what your blood type will be. Okay, so the ABO group, you have your two antigens, as I kind of briefly explained earlier. You have your A antigen, which is this yellow spiky shape here, and you have your B antigen, which is this blue spiky shape here. And let's look at this next slide here. A person can have the following combinations of antigens. So yes, sorry, if you have both your AB, if you have only A, you are A. If you have only B, you are B. If you have neither, you are blood type O. So there are four blood types of the ABO group. Blood type A. So if you have the A antigen, that's that yellow spiky thing. What you have in your plasma are anti-B antibodies. So if you're blood type A, your body is naturally equipped to notice blood type B and immediately attack it. 41% of the population is blood type A, as you can see from this pie graph here. This is from the United States, but I think the United States has a pretty good representation of the world. Blood type B, you're going to have the B antigen, and then your body's going to be naturally equipped to fight the A antigen. So it has these anti-A antibodies. And blood type B is about 10% of the population. Blood type AB, so when you have both A and B, you're going to have no antibodies, because if you had the anti-A or the anti-B, it would be attacking your own blood, and our body is built to not do that if we're blood type AB. And blood type AB is the rarest. Only about 4% of the population has blood type AB. Finally, we have blood type O. O has no antigen, so it doesn't have any of those spiky things on the outside. But a person with blood type O in their blood, they have anti-A and anti-B antibodies. Blood type O is the most common blood type, with 45% of the population having blood type O. So this diagram I really like. The last depiction had the spiky blue and yellow things. But I really like how they depict the antigens to have different shapes, because that's kind of how antibodies and antigens work. So you can see here this, for blood type A, they have these pink circular antigens on the outside. And if you cross over to the blood, here's my cursor. If you cross over to the blood type B here, the antibodies that are with blood type B are going to be, they're just going to be designed to attack blood type A. And you can kind of see this cross here. You can see how this diamond shape, this blue diamond, fits well into this anti-B antigen. So if a person with blood type A is exposed to someone with blood type B, their blood is mixed. It doesn't really happen naturally. Usually if someone is sick or they've been in an accident, they need blood. We want to make sure that we have compatible blood types. And we'll go into that a little more tomorrow for tomorrow's lesson. We see here the group AB has both the pink circle for the antigen A and the blue diamond for antigen B. And then blood type O, they have these like little hairs they look like, but they don't have any antigens on the outside, unless of course they're Rh positive. And we're going to talk about the Rh group separately, just to take things one step at a time. So you can see here the antibodies in the plasma of a person with blood type O. They're going to have both the A and the B, and no antigens in the blood. Okay, so let's talk about the genetics of the ABO group. So I had said that your blood type is inherited. You get it from your parents. If you remember back to grade 9, dominant and recessive traits, the blood type A and the blood type B, those alleles are dominant. So if you have blood type A, your phenotype is blood type A, but your genotype, so the genes that you carry, you can either be what's called homozygous dominant, so you can have both dominant traits, and it's depicted by this capital I with a little superscript A or superscript O. That is how it's commonly donated, but that's essentially, that just means double A. They can have one gene for blood type A and one for blood type O, and they're what's called heterozygous, so they have one dominant and one recessive, because I'll get to in a moment, but blood type O is recessive. If A and B are dominant, O is going to be recessive. Okay, the genetics for blood type B are very similar to blood type A. So you can be homozygous dominant, you can carry both B genes, or you can carry a B and an O, and you can still be blood type B. So when you have a recessive trait, it's called heterozygous. Sorry, that's my dog chewing on his toy. The genotype of a person with blood type AB, they have one A and one B. Because A and B are both dominant, a person with blood type AB is what's called co-dominant. So if you take genetics next year, you'll probably learn a little more about this. This is a little more advanced genetics, but the A and the B are both going to show their traits. So you'll have both A and B, and that's why we have the red blood cells that have the A and the B antigens present, is because of this thing called co-dominance. Okay, and the genotype of a person with blood type O, they're homozygous recessive. They have both traits to carry the O. So in order to be blood type O, you need to have two O's. If you have an A or a B with an O, you're gonna take on the form of blood type A or B. Kind of curious, if you think about the last slide, we had that pie graph that showed blood types in the United States. If blood type O is homozygous recessive, why is it the most common blood type? And I kind of did a little bit of research on that. It's because the blood types A and B are more recent mutations, and they just haven't really gone through the population as fast. Although they mutated like 20,000 years ago, I still think that is an interesting number, but that's just it, that blood type O is just an older trait. So you look at this table over here. This is just kind of summarizing. This is in your notes as well in the PDF or Word document if you downloaded those. If your genes are AA, you are blood type A. If your genes are AO, you are blood type A. If your genes are AB, you are blood type AB. If your genes are BO, you are blood type B. BB, you are blood type B. The only way you can have blood type O is if you are homozygous recessive, you have both traits, or both alleles for O. So thinking back to grade 9 and how to make a Punnett square. This is really hard to do on PowerPoint, so I'm sorry if this is not ideal. Draw a Punnett square. There we go. I didn't mean to have these letters in, but there's no other way to do it. So I've got my Punnett square here, I guess a 2 by 2, 4 squares in total. You want to set it up with the known phenotypes. So I'm pulling a hypothetical example. We'll do 2 kind of well-constructed examples in a moment. But I've got a female with blood type AB. She's got the A allele and the B allele, which means that she is going to show traits for a blood type AB. They're both going to show up. And they're having a child. The male has blood type A, but he is heterozygous. So he has one of the A's, and he's one of the A alleles, and he also has an O allele. So if we cross those, we're going to end up, the A's are going to cross on the first 2 boxes here. So we have one of the results can be a blood type A, which is homozygous dominant, because both of these squares have the A's. There is 25% chance that they could have a child with blood type AB. We've crossed the A with the B here. And 25% chance that you cross the B with the O and have blood type B. There's 4 squares in total. So if you don't look at these two, 2 out of 4 are blood type A, so that's 50%. 1 out of 4 AB, so that's 25%. 1 out of 4 blood type B, also being 25%. Sorry, enter gene combinations and determine possible phenotypes or blood types. So when I say phenotype or blood type, that is what shows up. So if you have this O, you're still going to be blood type B. I just kind of went over this here. 50% is going to be blood type A, and it's going to be homozygous dominant. If there was an O in here, it would be 25% homozygous dominant and 25% heterozygous, but both blood type A. 25% AB, co-dominant, and then we've got the heterozygous blood type B over here. So let's do an example. A woman with a genotype, 1 A allele, 1 O allele, so blood type A, heterozygous, and a man with a genotype AB have a child. So we want to know what blood type could the child possibly have, and what blood type could their child possibly not have. Some combinations are impossible, and we'll find that out here. So we've got our Punnett square set up. We've got our A allele and our O allele from the woman, and we have the A allele and the B allele from the man. We cross them together, so the A's come in here, the A and the O come in here, the B and the A come in here, and then the B and the O come in here. So if you look at what we have, there's a 50% chance their child will have blood type A. So they could either have 25% chance for the homozygous dominant to have the AA, 25% chance they could have the heterozygous, so the A and the O, but they will both show up as blood type A. This could be a carrier of the recessive trait. 25% chance your child will have blood type AB, that being co-dominant, that's that trait right here. And then 25% chance your child will have blood type B, and they'll only be heterozygous. There's no way it could be blood type B homozygous dominant. And then that question, what blood type or phenotype could their child possibly not have? Well, they're not going to have blood type O, because any case you have a blood type AB and you have a cross, it's not possible to have blood type O because of that co-dominant trait. These will both take over, and they will not allow blood type O to show. Okay, we've got another example here. A woman with a genotype, homozygous recessive, blood type O, so they've got 2 O alleles, and a man with genotype heterozygous, blood type B, so we've got 1 B and 1 O. What blood type could their child possibly have? What blood type could their child possibly not have? So we've got the woman on top here, we've got the 2 O alleles, we've got a B and an O allele here, and let's cross them. So the B goes in with the O to make 1 B and 1 O. The B goes in with the O there. The O goes in with the O up here, and then the O goes in with the O up down from over here. So if you look at our results, there is a 50% chance their child will have blood type O. So that's on the bottom here, and that's homozygous recessive. And there's a 50% chance their child will have blood type B, but it'll be heterozygous. So their child will always carry this recessive trait, probably because the mom had two O's up here. it is impossible for their child to have blood type A because neither of the parents demonstrate any characteristics for blood type A. And there's a 0% chance their child will be blood type AB because the A is missing. Okay, so we've covered the ABO group. Let's talk about something called the Rh factor or the rhesus factor. So blood cells can have the presence or absence of an antigen called the rhesus factor or Rh factor. When the Rh factor is present, the blood type is said to be positive or Rh positive. And when the Rh factor is missing, the blood type is said to be Rh negative, denoted here. If you look up to this diagram here, I really liked it because it illustrated the antigens. So if you're A negative, you're going to have this little purple diamond here to denote the A antigen. But if you're A positive, you're also going to have this little blue circle, the Rh antigen. B, you're going to have this little yellow diamond here to denote the B antigen. And then you're going to have this blue circle as well. I don't like this diagram because it doesn't include blood type O. Blood type O, you can have the Rh factor or you cannot have the Rh factor. So just keep that in mind, that there should be an O positive and an O negative over here somewhere, where the O negative is going to have no antigens at all, and the O positive is just going to have that little blue circle there. Most of the population is Rh positive, 85%, and 50% of the population is Rh negative. The Rh factor is genetically inherited, with the Rh positive being the dominant allele. So if you just look at any other Punnett square, the Rh is going to be dominant, and so Rh positive is going to be dominant, Rh negative is going to be recessive. So if you were to cross them, it'd be like any Punnett square from grade 9. Okay, so let's look at a couple incompatibilities. So if you mix blood types that are not what's called compatible, it can be problematic. So this can be problematic during a blood transfusion and for the Rh factor, especially for pregnancy. So the first time it happens, first time your body's exposed, an immune response is not likely to occur. Your body just kind of goes like, like, what are these different antigens in my body? But at first they don't act immediately because they don't have the antibodies built. But because they had been exposed to something that was different, your body is going to prepare for next time. So once you've been exposed, your body is going to stock up on anti-Rh antibodies. I should say that if you are Rh positive and you're given Rh negative blood, your body is going to ignore it because it already is accustomed to this antigen. So this really only occurs, you're only in trouble, I should say, if you're Rh negative and you're being exposed to Rh positive blood. So we've got a good example here. This is called erythroblastosis fetalis, sorry. So when you have a couple, they want to have a child, but they have Rh factors that are opposite, their child is at risk for having hemolytic anemia called erythroblastosis fetalis. And hemolytic, or I can't speak today, excuse me, hemolytic means destruction of red blood cells. So kind of like anemia where you have, your body's not producing enough. This type of anemia means that something is attacking your red blood cells, and that's obviously not good. So you got this diagram here. This only occurs when the mom is Rh negative, and it cannot occur if the mom is Rh positive. Like I had mentioned before, if you're Rh positive and you're exposed to Rh negative blood, we'll talk about compatibility in more detail tomorrow, where your body's just kind of like, oh, like I'm not bothered by Rh negative because I'm already used to the Rh positive factor. So if you have a dad who's got Rh positive blood, they have a child, and it's likely that their child is going to be Rh positive because this is a dominant allele. So what ends up happening is the pregnancy kind of goes as normal. Everything is okay. There's a little bit of seepage from the baby's fluids into the mom. But after she has her child, her body is like, what was that? My goodness, what were those Rh positive blood cells? So her body is going to produce antibodies to protect against this. If she was ever to be exposed to the Rh positive again, next time around, her body is prepared to fight those Rh positive blood antigens in the blood. So if not treated or not acknowledged or taken care of, if she becomes pregnant again and her child is again Rh positive, her body will start to attack the fetus. So it'll start destroying the baby's red blood cells, and obviously that's very problematic for development. I'll go into a little more detail here. Okay. So if the mother's Rh negative, father is Rh positive, there is a possibility that the child will be Rh positive. It is dominant, and 85% of the population is Rh positive. So what ends up happening is a bit of the blood mixes between the mother and the fetus, and the mother will start producing Rh antibodies. And it's okay for the first pregnancy because her body like hasn't produced a lot. It's still kind of like, what was that strange other blood type? There's not going to be a large accumulation of these antibodies in the mother's body. But after she has her child, her body is going to produce a ton of antibodies. So if this doesn't go treated, or it's not acknowledged or taken care of, if she has another child and it's Rh positive, her body will start attacking the fetus and destroying its red blood cells, which is terrible for development. However, due to modern medicine, this can be very easily negated. So after she has her first child, she's going to receive an injection of these anti-Rh antibodies, which are going to neutralize the antibodies after she's given birth. So essentially at this point here, she'll receive an injection that's going to destroy these Rh antibodies, so that if she decides to have a child with her husband or a partner who is Rh positive, everything is going to be okay because these antibodies won't exist with this anti-Rh antibody solution. A lot of negatives there. Okay, so that concludes this lesson. Let's talk about the assignment. If you've been taking notes and you prefer to just send me a couple snaps or scan your notes, I'd be happy to take those as part of assessment. But today's assignment is only 3 questions. I want you to compare and contrast antigens and antibodies. Where are they found? Specifically, I want you to know where they're found in red blood cells. What are the possible genotypes of a person with type A blood and type B blood? So this notation here, where you have the alleles, I have the X's just because like X is like a variable, doesn't mean anything. You can put an A or a B or an O in there. But if you're typing it out on the computer, don't worry about the superscript. You can just leave it in the regular spot. I just like that notation a lot, and that is the proper notation. But I don't think it's possible to do the superscript in forms. And then I want you to talk about erythroblastosis fetalis. And I want you to tell me what causes it, how can it be treated, maybe like why is it not harmful off the hop, but more harmful for later pregnancies, etc. All right, so that is lesson 7. Thank you for listening along. I hope you learned lots. If you have any questions, you can send me a note. If you need practice or help with the Punnett squares, please send me a note. I'll maybe try to put out some extra practice if folks are asking for it. But yeah, thanks for joining me. Have a great rest of your day.